Hey everyone, welcome back to the channel. You know, when we think about dinosaurs, we usually picture them roaming Earth millions of years ago. But what if I told you there's a chance, however slim, that dinosaur fossils could exist somewhere out there in the vastness of space? Imagine a rover trundling across the Martian surface and stumbling upon a perfectly preserved T-Rex tooth, or a lunar rover digging up a Stegosaurus plate. It sounds like something straight out of a science fiction movie, right? But the universe is full of surprises, and the more we learn about it, the more we realize that almost anything is possible. So, how could dinosaur fossils end up in space? What would it mean for our understanding of life beyond Earth? And what would scientists do if they ever found such a thing? Let's dive in and explore these cosmic possibilities together. Now I know what you're thinking, dinosaur fossils in space, it sounds like something straight out of a science fiction novel or a blockbuster movie. That's a pretty wild idea, isn't it? And you're right, it is. But sometimes the wildest ideas can lead to the most fascinating discoveries. But before we dismiss it as pure science fiction, let's consider the possibilities, because the universe is full of surprises. The universe has a funny way of making even the most outlandish ideas seem plausible. After all, who would have thought that we'd find water on the moon or organic molecules on Mars? For a dinosaur fossil, or any fossil for that matter, to exist in space, one of two extraordinary things must have happened. Let's dive into these intriguing scenarios. First, let's talk about a cosmic game of billiards. Imagine the solar system as a giant pool table with asteroids and comets as the balls. You see, our solar system is a pretty busy place, with asteroids and comets zipping around all the time. These space rocks are constantly on the move, sometimes colliding with each other or with planets. And sometimes those space rocks collide with planets, including our own. These collisions can be incredibly powerful, sending shock waves through the planet's surface. Now imagine a massive asteroid much larger than the one that wiped out the dinosaurs, slamming into Earth millions of years ago. The impact would be catastrophic, altering the course of life on our planet. The impact would be catastrophic, no doubt, but it could also launch enormous amounts of Earth's crust into space. This debris could travel vast distances, potentially carrying with it pieces of our planet's history. And I mean enormous. We're talking billions of tons of rock hurled into the void. These rocks could drift through space for eons, carrying with them the secrets of ancient Earth. Some of this ejected material would carry with it remnants of Earth's history, including, you guessed it, fossils. These fossils could be from dinosaurs or other ancient life forms that once roamed our planet. These rocky arcs carrying the fossilized remains of dinosaurs and other ancient life would then embark on a cosmic journey, potentially landing on the moon, Mars, or even drifting further into the solar system. Imagine the stories these rocks could tell. Now, imagine a rover, like Perseverance on Mars, or maybe even a future human explorer, stumbles upon a curious rock formation. They might find something that changes our understanding of life in the universe. They dust it off, and lo and behold, it's a fossilized bone fragment. This discovery would be groundbreaking, opening up new avenues of research and exploration. The discovery would send shockwaves through the scientific community. It would challenge our understanding of life's history and its potential spread across the cosmos. But before anyone starts celebrating, they'd need to answer a crucial question. Did this fossil hitch a ride from Earth, or did it originate on the very planet where it was found? This question would be at the heart of the scientific investigation. That brings us to the second, and perhaps even more mind-blowing possibility. What if dinosaurs, or at least something resembling them, existed on another planet entirely? Could life have evolved in a similar way elsewhere in the universe? We've already discovered thousands of exoplanets orbiting distant stars, and many of them are rocky worlds located within their star's habitable zone, where conditions might be just right for liquid water, and potentially, life as we know it. These planets could be teeming with life forms we've never imagined. Now imagine for a moment that life did arise on one of these exoplanets. What kind of creatures might have evolved there? Could they have left behind fossils that we might one day discover? What's more, imagine that life followed a similar evolutionary trajectory to life on Earth. Could there have been a period in that planet's history when creatures akin to dinosaurs roamed its surface, leaving behind fossils that are just waiting to be discovered? Could there have been a period in that planet's history when creatures akin to dinosaurs roamed its surface, leaving behind fossils that are just waiting to be discovered? The implications of such a discovery would be staggering. If we found fossils on another planet or asteroid, fossils that didn't come from Earth, it would be one of the most profound discoveries in human history. It would fundamentally change our understanding of life in the universe. It would mean that life, in some form, is not unique to our pale blue dot. It would suggest that the building blocks of life are common throughout the cosmos. It would mean that the universe is teeming with the potential for life, and that we are not alone. The search for extraterrestrial fossils is not just about finding ancient bones, it's about understanding our place in the universe. Let's say we're exploring the solar system and our intrepid rover sends back images of a strange, bone-like structure on Mars, or maybe even on a distant moon like Europa or Titan. These celestial bodies have long intrigued scientists due to their unique environments. How would scientists here on Earth determine if it's a genuine fossil or just a weirdly shaped rock? The process is meticulous and involves several steps. Well, the first thing scientists would do is analyze the chemical composition of the find. This initial step is crucial for distinguishing between organic and inorganic materials. Fossils are more than just rock. They contain specific minerals and elements that hint at their organic origins. These minerals often replace the original organic material over time. For example, fossilized bones often contain high concentrations of calcium phosphate, a key component of bone tissue. This mineralization process is a hallmark of fossilization. If the chemical analysis checks out, the next step would be age dating. Determining the age of the specimen helps place it within a historical context. Scientists use various radioactive dating methods to determine the age of rocks and fossils. These methods rely on the predictable decay rates of certain isotopes. By comparing the ratios of different isotopes, they can estimate how long ago the fossil formed. This information is vital for understanding the fossil's place in the timeline of life. This is crucial for understanding the object's place in geological time. It helps scientists piece together the history of life on the planet. But the real smoking gun, the undeniable proof of ancient life, would lie in finding microfossils. These tiny remnants can tell us a lot about the past. These are the microscopic remains of bacteria, algae, or other tiny organisms that get trapped within larger fossils or rock formations. Their presence is a strong indicator of past life. Imagine finding fossilized remnants of single-celled organisms inside that bone-like structure on Mars. Such a discovery would be monumental. Scientists would use powerful electron microscopes to search for these microscopic clues, analyzing their shape, structure, and chemical makeup. This detailed analysis can reveal much about the organism's biology. If the microfossils resemble known forms of ancient life, it would strengthen the case for a genuine fossil. This comparison is essential for validation. However, things get really interesting if the fossil doesn't match any known Earth-based life forms. This would open up new avenues of scientific inquiry. Imagine finding a fossil with a completely alien biochemistry, something unlike anything we've ever encountered. This would challenge our understanding of life itself. Such a discovery would be groundbreaking to say the least. It would capture the imagination of scientists and the public alike. It would mean that life on this other planet evolved independently of life on Earth, following its own unique path. This would have profound implications for our understanding of biology. It would suggest that the universe is a far more diverse and wondrous place than we ever imagined. The possibilities for discovery would be endless. Finding a fossil from a truly alien life form would be like deciphering an extraterrestrial message, a message that says, "You are not alone, and the universe is teeming with possibilities." This would be a monumental shift in our understanding of life and our place in the cosmos. Chapter 3. What would be the impact of finding a fossil in space? The discovery of a dinosaur fossil, or any ancient remains for that matter in space, would be a monumental event. A paradigm shift in our understanding of life, the universe, and our place within it. It would be a discovery that challenges everything we thought we knew about the origins and distribution of life. It would ignite our collective imagination and spark a new era of scientific exploration, pushing the boundaries of what we believe is possible. First and foremost, it would be the ultimate confirmation that life in some form is not confined to Earth. This would be a groundbreaking revelation. It would mean that the seeds of life, those miraculous ingredients that give rise to complexity and consciousness, are not unique to our pale blue dot, but rather scattered throughout the cosmos. This would suggest a universe teeming with potential for life. This discovery would revolutionize the field of astrobiology, the study of life in the universe. It would open up new avenues of research and inquiry. It would provide concrete evidence to support what was once considered mere speculation, fueling a global effort to search for more signs of extraterrestrial life. The scientific community would be galvanized. Imagine the implications for our understanding of evolution. It would challenge our current theories and models. Finding a dinosaur-like fossil on another planet would suggest that life, even when separated by the vast gulfs of space, might follow similar evolutionary paths. This would be a profound insight. It would mean that the pressures of natural selection, the drive to survive and reproduce, could lead to the emergence of complex, even intelligent life forms on other worlds. This would be a monumental realization. The discovery of a fossil in space would undoubtedly trigger an unprecedented surge in space exploration. The excitement would be palpable. Space agencies like NASA, ESA, and others would pour resources into studying the fossil up close. The race to understand this new find would be on. We'd see a new generation of robotic missions designed to collect samples, analyze the surrounding environment, and search for more evidence of past or present life. The technology and methods would advance rapidly. This discovery could even lead to the development of entirely new scientific disciplines like space archaeology, dedicated to studying and preserving extraterrestrial fossils and artifacts. This would be a new frontier for science. We might even develop international laws and treaties governing the handling and protection of these cosmic treasures, recognizing their immense scientific and cultural value. The global community would need to come together. The impact of finding a fossil in space would extend far beyond the scientific community. It would touch every aspect of human life. It would touch every aspect of human culture. From our art and literature to our philosophy and religion, the ripple effects would be felt everywhere. It would force us to confront our place in the universe in a profound way, reminding us that we are part of something much grander than ourselves. This would be a humbling and awe-inspiring realization. While we haven't found concrete proof of dinosaur fossils, or any fossils for that matter, beyond Earth just yet, the possibility is tantalizing. Scientists believe that Earth has been shedding pieces of itself for billions of years, sending debris containing potential traces of ancient life to other worlds. Imagine one day, we find definitive proof, a fossil that undeniably originated on another planet. It would be one of the most significant discoveries in human history, fundamentally changing our understanding of life and our place in the universe. It would prove that we are not alone, that the universe is teeming with possibilities we can only begin to imagine. What do you think? If we found a dinosaur fossil in space, should we bring it back to Earth for further study? Or should we leave it untouched, preserving it in its original cosmic context? Let me know your thoughts in the comments below. And as always, keep looking up.